Hi everyone, this is Jayashree, Assistant Professor, Department of EEE. Today we discuss upon construction of DC generator. So we are continuing with yesterday's topic. Construction of DC generator means both DC machines and DC generator construction is same because the machine is same. Based on the input, it behaves like a motor or a generator. Okay, right. So we discuss construction of a DC machine. Right. So major it consists of stator and rotor main components. Stator is a static part. Rotor is a rotating part. Stator consists of yoke or frame, that is the outermost part which provides mechanical support to the generator. We call it as a yoke. It is made of cast iron and steel. Second one is pole core or pole shoes. So here we all know all electrical machines works on electromagnetic induction principle. So they all are electromagnets. Okay. So it consists of coils and pole core. So second major component is pole core and pole shoes. Third one is field poles, which houses field winding and interpoles also there. Right. Then second major component in a DC machine is a rotor. Rotor is a rotating part inside the DC machine. It consists of armature core and armature winding. Second one is commutator. Third one is brushes. We discuss upon one by one. Right. So look into this picture. This is a front view, cross-section view of a generator. Right. So look out the outermost part. This thing we call it as a yoke. That is outer frame. It is made of cast iron or steel. Inside that, there are four poles. In this machine, it consists of four main poles: North Pole, opposite North Pole, South Pole, South Pole. These are four poles. So, which is fixed in the stator frame. Right. So, this part, we call it as a pole core. It is made of iron, steel laminations of 0.5 mm thickness, which are bolted, stacked, and it is formed like a block. It looks like a block of iron, but it is made of iron laminations, right? Then surrounding that field coils, that is field coils are present. So in these four are main poles. In between that, there are four interpoles. So this one, two, three, four, these are interpoles, right? This is a stator part. Then middle one is a rotor, which is a rotating part. So look into this. This is semi-closed type of slot in armature core. So it is open, semi half closed and half open. In between that, the small circle, it represents the conductor, armature conductor, armature windings, right? Then in the middle portion, this one is a commutator, which converts that is alternating current into direct current. It is made of copper. So this thing we call it as a commutator segment. The middle portion is a shaft or key, which houses the entire rotor part. Right. So we'll look into this one by one. This is a yoke, which consists of a terminal box. From that, the supply is given to the motor. Otherwise, the electricity supplied that is generated from the generator is taken out from the terminal box. Right. So this one is yoke. Next one is a pole core. See in this picture, there are four poles and four interpoles. Right. Next one is see this portion we call it as a pole shoe, which spreads the flux evenly inside that machine. So inside that machine, the flux is present in the air gap. This pole shoe spreads the flux uniformly inside the machine. Right. So in the pole shoe acts as a support to the field coils and spreads out the flux laminated of the annealed steel of thickness. This is of thickness 1 mm to 0.25 mm. Right. Then the purpose of field coils is provide excitation. It provides excitation, that is, it provides field flux. Then next one is armature core. See, this is armature core. It is made of laminations. It is made of high grade silicon steel to reduce hysteresis loss and eddy current loss. This is armature core. Then armature winding. Armature winding is made of copper or aluminum. There are two types of armature winding. One is lap winding. Second one is wave winding. So lap winding, you all know lap from the name itself. You can understand that. Okay. Understand like in a race, how the lap is present. First lap, second lap, third lap, fourth lap. This is of like a lap form. In this way, the winding is wound like a lap, one above another, one above. Then second one is wave winding. So the winding is like a wave. How the wave will be? It is like it is moving, it is moving, it is moving, it is moving like that. It is moving like a wave. It is opposite diagonally opposite poles. It is wounded. So it is a wave winding. So there are two types of winding. So first one is lap winding. Second one is wave winding. Is coming to brushes. Brushes is made of copper or carbon graphite. It is made of to collect the current from the commutator. Commutator is made of copper segments. It is present between armature and external circuit, and it acts like a rectifier which converts AC to DC. So these are all the parts in a major parts in a generator. Thanks for watching. Thank you. We will discuss the principle of operation of generator in the next class. Thank you.